Hello everyone, welcome to another online math lesson. Our lesson for today is the properties of a parallelograms. And as we go on with our lesson, we'll be able to solve problems involving angles and sides. Now before we start, let's talk about quadrilateral because our topic for today involves quadrilaterals. Now what do we know about quadrilateral? A quadrilateral is a polygon with four sides. And if it has four sides, therefore all angles add up to 360 degrees. Quadrilaterals have several special types of shapes. We have the parallelograms, we also have the trapezoids, and the kites. And our topic for today mainly focused on the parallelograms. Now, a parallelogram has four basic properties, and I will be discussing each one of those properties with examples. The first property is that opposite sides are parallel and congruent. Second is opposite angles are congruent. Third, consecutive angles are supplementary angles. And the fourth one, diagonals bisect each other. Now I'll be discussing each of these properties with examples for you to understand properly when can a parallelogram or a four-sided polygon be considered as a parallelogram. For a four-sided polygon to be considered a parallelogram, it should meet these four properties. Now, we have here the first property. We have here our figure. Let's try to prove that this figure is a parallelogram. The first property says opposite sides are parallel or congruent. We know that the word congruent means equal in measure, right? So we have here the symbol of congruency. We have here the single bar and a double bar. Now this means that line AB and line BC, which are opposite to each other, are congruent. This symbol is a symbol of congruency or equality. So line AD and BC are equal in length. And also line AB and line DC, opposite sides, parallel to each other, also equal in length. This is what the double bar means. Okay, for example, I have here the value of my line AB is equal to 12. Therefore, if this is a parallelogram, then side DC is also equal to 12. And if we incorporate this one using the algebra, if I have here my line AD equal to 3x plus 6 and my line BC equals to 4x minus 1, now to prove that this figure is a parallelogram, we can use the property of a parallelogram that opposite sides are parallel and congruent. Then I can say that line AD is equal to line BC because this is what this property means, that the opposite sides are equal in length. Now let's see. Let's try to prove. So I have here my line AD is equal to 3x plus 6 equals to my line BC, which is equal to 4x minus 1. Now from here, this is just basic algebra, right? Now we can solve this one using the um, additive inverse method to solve for the variable x. Now, how do we solve for the variable x here? We need to group terms with variables and the terms which are constants. We need to group them together, which means on the other side of the equations will be our terms with variable, and on the other side of the equation will be our term which are constant. Now, how do we do that one? We have two methods. Either we use the textbook method, which is the proper way, using the additive inverse. So for this case, in this case, I'll be using the additive inverse, but on our next examples, I'll be using the next method, which is the shortcut of the additive inverse, which is called the transposing method. Okay, so for this first example, to solve for the variable x, I'll be using the additive inverse. How to use the additive inverse? Simply by the word inverse and add, you need to add an inverse of a certain term. Now, since our target here is to group similar terms on the other side and similar terms on the other side of this equation, so I want my variables to be on the left side and my constants on the right side. So let's start. Now, for that to happen, I need to eliminate the constant here. So since 6 is positive, I'll add a negative 6 here. So remember, what you do in the other side of the equation should be done also on the other side of the equation. If you add a negative 6, then you'll add a negative 6 also here. So that positive 6 and negative 6 will cancel out. So I already eliminate the constant on the other side. So what's left is the 3x. Bring down the equal sign. 4x does not have any similar term here, so I'll just bring down 4x. Negative 1 plus negative 6 is equal to negative 7. There. Now, this time, since my plan is the variable should be on the left side and constant should be on the other side, so I'll eliminate this one. Now, since 4x is positive, I'll add a negative 4x here. Again, what you do on the other side should be done also on the opposite side. Now, from here, positive 4x and negative 4x is equal to 0. So I can cancel that one out. Positive 3x plus negative 4x will give me negative x. I'll bring down the equal sign. And since this one is 0, what's left is negative 7. We're almost there. Since x has a numerical coefficient of negative 1, because of this one, to eliminate that one, we'll just divide both sides by a negative 1 and a negative 1. So negative 1 divided by negative 1 is positive 1, and then 1 becomes an imaginary number, so what's left is x. Negative 7 divided by negative 1 is equal to positive 7. Now, from here, let's try to substitute the value of x here for us to know the exact length of line AD and line BC, and see if we could come up, or if the value of x here will prove that this figure is indeed a parallelogram, wherein opposite sides not only parallel but also equal in length. Now let's see. Let's try to substitute the value of x here. 3x plus 6. My value of x is equal to 7 plus 6. 3 times 7, that is 21, plus 6. 21 plus 6 is equal to 27. So this is my value of AD, that is 27. Let's try to prove if BC is also equal to 27. Let's try to substitute the value of x. 4x minus 1. The value of my x is equal to 7. 4 times 7, that is 28. Minus 1. 28 minus 1, that is equal to 27. Therefore, this figure is a parallelogram. Opposite sides are parallel and congruent. Okay, so next, let's proceed to the second property of a parallelogram, wherein it says opposite angles are also congruent. So it means that angle A here should be equal to angle C. The opposite of this angle is angle C. And angle B should also be equal to angle D for this figure to be considered a parallelogram. For example, if my angle A is equal to 100 degrees, angle C should also be equal to 100 degrees, right? Now, what if my angle D is equal to 5x minus 20 and my angle B is equal to 3x plus 20? Let's try to prove or try to solve x and see if angle D would be equal to angle B given this algebraic statement or expression. So let's see. Opposite angles are congruent, meaning equal in value. Then for here, we can just write 5x minus 20, that is my D, equals to my angle B, which is 3x plus 20, right? Now from here, again, this is just basic algebra. Now since I'm using the um, additive inverse, which is the proper way in solving for an unknown variable in an algebraic equation, this time I'll be using the shortcut of the additive inverse for us to save time, especially in solving problems. Now in this case, again, we have the same target. I want to group terms with similar terms on the other side and similar terms on the other side of the equation. Now my target here is my left side of the equation should be the variable x, terms with the variable x, and on my right side will be the constants. So how does the um, transposing method works? So the transposing method works like this. Since my plan is variables on the left side, I'll transpose this one here. Transpose meaning transfer. And since 20 is a constant, I'll transfer that one here. Now, this is very important for this shortcut method to work. If you transpose a term to the other side of the equation, the sign of that term will change to the opposite. Meaning, if the constant here, positive 20, be transferred to the other side of the equation, the sign of this one will change into negative. So as the positive 5x here, if I'll transfer that one to the other side of this equation, that becomes negative 5x. Now let's go. I'll bring down 3x. And since I transfer this one to the other side of the equation, 5x is positive, that becomes negative. Okay, bring down the equal sign. What's left here is negative 20, right? Because I already transferred that one. Now, my positive 20, I'll transfer it here to the other side of the equation. The sign changes to negative. There. Now, this is just a simple combining of terms. So, 3x minus 5x, this will give me negative 2x. Negative 20 minus 20, so we have like sign. We need to add them together, so you have negative 40. I need to solve for the variable x. I need to eliminate this numerical coefficient. The only way to eliminate this one is to divide it by itself and also on the other side. Negative 2 divided by negative 2 is equal to positive 1. 1 becomes an imaginary number, therefore what's left here is x, or 1x. Positive 40 divided by negative 40 divided by negative 2, this will cancel out the negative sign, so what's left here is positive 20. This will be the value of my x. Now let's try to substitute this value to the given statement here. Now, and then let's try to see if this figure is indeed a parallelogram, if this angle equates to this angle. Now let's see. We have 5x minus 20 for angle D. Let's substitute the value of x, which is equal to 20 minus 20. 5 times 20, that is 100, minus 20. 100 minus 20, that is equal to 80. Now let's try to substitute it also here, angle B, see if we could come up with an 80 also. So 3x plus 20, my x is equal to 20 plus 20. 3 times 20, that is 60, plus 20 is equal to 80. Therefore, this figure is a parallelogram because angle D is equal to the opposite angle, which is angle B. But let's not stop here. On our earlier discussion, if we have a four-sided polygon, the total inside angle should equate to 360. Can you still remember that one? Now let's try to see if this four-sided polygon has a total inside angle of 360. So you have 100 plus 100, that's 200, plus 80, that's 280, plus 80, 360. Now this is already a four-sided polygon and also a parallelogram figure. Now let's proceed to the third property of the parallelogram, which is consecutive angles are supplementary. Now if you try to look at here, line AB is parallel to line DC. If you can still remember the transversal theory, or that been discussed to you during your grade 8 year, the transversal parallel line being cut with a transversal line, which is this one. Now, if this parallel line being cut with this transversal line, it means that these angles here are consecutive interior angle. And based on that lesson, we know that consecutive interior angle are supplementary angle, which equates to 180 degrees. So as this line here or angle here, if line AB is parallel to line BC and being cut with a transversal DC, meaning angle D and angle C are also consecutive angles. Therefore, they are also supplementary angle, which equates to 180. So if I have here my angle A equal to 120 degrees, angle B should be 180 minus 120. They should equate to 180. Therefore, angle B should be 60 degrees because A and B are supplementary angles. And if B and C are supplementary angles, therefore angle C must be 120 degrees. And if angle C and angle D are supplementary angles, then angle D should also be 60 degrees. Now what have you noticed here? This is also the property or the second property of a parallelogram. Opposite sides are equal or congruent, right? Now let's try to incorporate algebra here. For example, my angle B is equal to 3x plus 10 and my angle C is equal to 7x minus 30. Let's try to solve for the exact angle for angle B and angle C by solving for the value of x. Now we know that angle B and angle C are consecutive angle, therefore they are supplementary angle and equates to 180 degrees, right? So angle B plus angle C is equal to 180 degrees. If angle B is equal to 3x plus 10, adding it with angle C, which is 7x minus 30, they should equate to 180. Now from here, again, this is basic algebra. So I'll use the transposing method again to save time. Again, I want my variables on the left side of my equation and the constant on the right side of my equation. So I'll start transferring term here or transposing term to the other side. By positive 10, I'll transpose that one because that is a constant. Negative 30, I will also transfer that one here because that is a constant. Now since my variables are already on the same side of the equation, so I'll just transfer the constant here. So I'll bring down 3x plus 7x, bring down my equal sign. So on my left side, I have my 180. And then the transposed term, positive 10. Again, if you transpose a term to the other side, the sign of that term will change to the opposite. So positive 10 becomes negative 10. Negative 30 becomes positive 30. There. Now let's combine terms. 3x plus 7x is equal to 10x. 180 minus 10, that's 170, plus 30, that is 200. Now we need to solve for the variable x. We need to eliminate the numerical coefficient. The only way to eliminate this one is to divide it by itself. 10 divided by 10 is equal to 1. 1 becomes an imaginary number, so what's left is x. 200 divided by 10, that is equal to 20. Now let's try to substitute this value of x to our statement here. So let's start with angle B. 3x plus 10. My x is equal to 20. 3 times 20, that is 60, plus 10, this is equal to 70. Now let's try to substitute it here. 7x minus 30, 7 times 20 minus 30. 7 times 20, that is 140, minus 30. 140 minus 30 is 110. 70 plus 110 is equal to 180. Therefore, the angle B is equal to 70, angle C is equal to 110. So this proves that this figure is a parallelogram because consecutive interior angles is equal to 180 degrees. Now let's proceed to our fourth property of a parallelogram, which is diagonals bisect each other. So if I draw a diagonal line from point A to point B and another diagonal line to point B to point D, so from A to C, B to D, I have my diagonal line here wherein I have the center, I label that one as O, point O. So it's the fourth property of a parallelogram says diagonal bisect each other. So from the word bi means the diagonal passing through the other diagonal cuts this diagonal into half. Meaning, if this side is 12, this side must also be 12. And if this side is equal to 16, this side is also equal to 16. This is what the fourth property of the parallelogram means. Now, again, for a four-sided figure to be considered a parallelogram, it should meet the four properties or the four basic property of a parallelogram. First, opposite sides are equal and congruent. And then opposite angles should be equal. Third, um, consecutive internal angles should add up to 180 degrees. And lastly, the diagonals bisect each other, meaning this half here should be equal to this one. Before a certain four-sided figure to be considered a parallelogram. And that's it for now. Thank you for listening.